The pictures coming back from the James Webb Space Telescope, they just shouldn't exist. We're seeing things that are forcing us to question the very foundations of our understanding of the universe. The most powerful telescope ever built is sending back postcards from the dawn of time, and what it's finding is not what anyone expected. It's found a whole population of galaxies that, according to our theories, are just too big, too bright, and too complex to exist so early in cosmic history. And now, some of the most respected minds in physics are weighing in, suggesting this isn't just a minor puzzle, it's a sign that our entire story of how the universe began might have a few chapters missing. For decades, we've told ourselves a pretty consistent story about our universe. It all starts 13.8 billion years ago with the Big Bang. In this story, the first billion years were a quiet, gradual process. Gravity slowly and patiently gathered the first wisps of gas, coaxing them into the first stars. Over hundreds of millions of years, these collections of stars would gradually come together to form the first baby galaxies, small, faint, and a bit messy. That was the story. That was the prediction. To finally see this cosmic dawn, we built a time machine, the James Webb Space Telescope. Perched 1,000,000 miles from Earth, its massive golden mirror is designed to do one thing better than any instrument in history: look back in time. Because light travels at a set speed, looking at distant objects is literally looking into the past. Webb is so powerful, it can see the light from galaxies that existed when the universe was just a toddler, only 2 to 3% of its current age. It does this by seeing in infrared, a spectrum of light our eyes can't perceive. This allows it to peer through the cosmic dust that usually blocks our view and to catch the faint, ancient light from the edge of the known universe. Scientists knew Webb would be revolutionary. They had models and a clear picture of what they expected to find. What they didn't expect was for Webb's snapshots to tear that picture apart. In early 2023, the data started pouring in, and so did the confusion. Astronomers found galaxies that, according to our best models, simply were impossible. They found a shocking number of massive galaxies that existed between just 300 and 700 million years after the Big Bang. To put that in perspective, finding a galaxy that mature so early in the universe is like finding a fully grown adult who claims to be 6 months old. It doesn't just bend the rules, it shatters them. The standard model of cosmology, which has guided our understanding for half a century, just doesn't allow enough time for galaxies to get this big, this fast. And it wasn't a one-off. Webb kept looking, and it kept finding them. It found JWST Z14-0, a surprisingly bright and large galaxy seen just 290 million years after the Big Bang, making it one of the distant galaxies ever confirmed. The light from JWST Z14-0 suggests it's powered by young stars, not a central black hole, meaning the galaxy itself is genuinely massive and formed with incredible speed. These discoveries show that luminous, massive galaxies were already in place far earlier than theories predicted. Scientists have double and triple checked the data. They've questioned their assumptions, but the conclusion is becoming inescapable. The objects are real. The story we've been telling ourselves about the early universe was, at best, incomplete. The universe was making huge galaxies far faster than we ever thought possible. This is where the story turns from a scientific curiosity into a genuine challenge for cosmologists, and it's why some of the sharpest minds in physics are pointing out the tension. One of those minds is Dr. Adam Rice, a Nobel Prize-winning astrophysicist from Johns Hopkins University. Rice won his Nobel Prize for co-discovering that the universe's expansion is accelerating, a force we call dark energy. He is one of the architects of our modern cosmic model. Rice stated that with observational errors being ruled out by the precision of telescopes like Webb, what remains is the real and exciting possibility that we have misunderstood the universe. This isn't hyperbole. It's a frank admission from a scientist of his stature that the evidence is challenging the foundations of his field. He emphasizes that discrepancies between what we predict and what we see are an incredible opportunity to learn more about our cosmos. The impossible galaxies are a profound puzzle that is forcing a reevaluation of how things got started. This has opened the door for more radical ideas to get a hearing. For years, Nobel laureate Sir Roger Penrose has championed an alternative theory called conformal cyclic cosmology, which suggests our universe is one in an infinite series of cycles. While this idea remains on the fringe of mainstream science and lacks direct evidence, the fact that Webb's data is generating such profound puzzles is causing scientists to question everything, pushing the boundaries of what we consider possible. So, what is this standard model that's now facing such a stress test? Its technical name is Lambda CDM. Think of it as the universe's operating system. It's a set of rules and ingredients that has been incredibly successful at explaining almost everything we see. The ingredients are about 5% normal matter, us, stars, planets, 27% cold dark matter, and 68% dark energy, or lambda. This model has worked beautifully for decades, but the JWST's findings are like a critical error message. The OS just can't account for these early massive galaxies. So what now? The debate is heating up. Some researchers are trying to find a patch. Maybe star formation in the early universe was just hyper-efficient in a way we don't understand. Or maybe the initial distribution of stars was top-heavy, with more massive stars than we see today, which would make early galaxies look brighter and mature faster. But a growing number of scientists wonder if a patch is enough. The system itself might be flawed. What if dark matter isn't so cold and slow-moving? What if fundamental forces were different at the dawn of time? This is connected to another huge puzzle in cosmology, the Hubble tension, a persistent disagreement over how fast the universe is expanding today. While newer JWST data has helped refine measurements, it hasn't solved the tension. In fact, the work of Reese and his team has confirmed the discrepancy remains. These new galaxy discoveries just add more fuel to this fire of cosmic uncertainty. The strangeness doesn't stop with these impossible galaxies. Webb has also found other puzzling signals. For instance, while observing the distant galaxy Jade's GS-Z13, it detected a surprisingly strong signal of a specific type of light known as Lyman alpha emission. Here's why that's weird. In the first few 100 million years, the universe was filled with a thick fog of neutral hydrogen gas that should have completely absorbed that exact kind of light. Seeing such a strong signal from that far back is like seeing a lighthouse beam perfectly clearly through a fog so dense that it should be totally blacked out. This discovery challenges our timeline for a key event called reionization, the period when the first starlight burned through this cosmic fog and made the universe transparent. Finding this light suggests that pockets of the universe cleared out much, much earlier than we thought, for reasons we don't understand. It's another clue that the cosmic dawn was far more rapid and complex than our tidy models predicted. These are the kinds of questions that are now defining the cutting edge of astrophysics. The clues are scattered across billions of light years, hidden in the faint glow from the universe's first light. If you find these cosmic mysteries as fascinating as we do and want to follow the story as it unfolds, make sure to subscribe and hit that notification bell. You won't want to miss what we uncover next. The James Webb Space Telescope was built to answer our biggest questions about the universe. Instead, it's shown us that we might not have even been asking the right questions. The triumph of its engineering has led us to a profound new scientific puzzle. The standard model, for so long the bedrock of our understanding, now faces one of its greatest challenges. But this isn't a failure. This is the scientific process at its most thrilling.
Every great leap in our knowledge has started with a moment just like this one, a moment where the evidence no longer fits the theory. It's in these moments of confusion that revolutions happen. The universe has just thrown us a curveball that traveled for over 13 billion years to reach us. And now the world's most brilliant scientists are stepping up to the plate, ready to rethink everything. What they discover next won't just tweak a few equations. It could rewrite the story of everything.